Okay, so in questions 8, 9, 10, and 11 for the exercises, we're looking at 9.4 and 9.5, and we're looking at two opposite processes. Voltaic cells, which is like electroplating is what you would know it as. And when we're doing this, the anode is always where the oxidation takes place. So even when we get to 9.5 and we look at electrochemical cells, which is basically a battery, the anode is still where oxidation takes place. So concentrate on the half reactions rather than the substances in there. So it says use the metal reactivity series to predict which electrode will be the anode, which will be the cathode when the following half cells are connected, and write the half equations. So with A, what I need to decide is which is the more reactive metal. And if I look at my reactivity series, Zn is more reactive than Fe. So that means zinc metal will lose electrons. So that's going to be my anode, or it's going to be oxidized. And Zn then is going to become Zn2 plus. Move that down just a little bit. Zn2 plus 2 electrons. Well, Fe is going to start out as an ion. It's going to pick up the 2 electrons and be reduced to Fe. Well, in example B, I've got Fe and magnesium. Magnesium's more reactive than iron metal, so magnesium is going to be oxidized and become Mg2 plus 2 electrons, and Fe again is going to be reduced to iron metal. And then C, Mg versus copper. Mg is more reactive than copper. So Mg is going to be oxidized to Mg2 plus and 2 electrons. Well, copper ion is going to be reduced and gain those 2 electrons to become copper metal. Then if we scroll on to number 9, okay, so for number 9, it says draw a voltaic cell with one half cell consisting of magnesium and a solution of magnesium ions, the other zinc and a solution of zinc ions. Label the electrodes with the name and charge, the direction of electron and ion movement, and write equations for the reactions occurring at each electrode. So here's voltaic cells made easy once again. I've drawn everything in. We know the electrons are going to flow through the wire, either magnesium to zinc or zinc to magnesium, and we know the salt bridge is going to have anions going one way and cations the other. So really our question here is which is the more reactive metal? And so if you look at a reactivity series, magnesium is more reactive than zinc. That means magnesium has to lose electrons or be oxidized. And that means this is the anode, because remember the anode is any oxidation is going to occur there. So magnesium losing electrons, this is going to be negative because when you lose electrons, there's a buildup of electrons here, even though they're going to flow the other way. So I've got magnesium becoming Mg2 plus 2 electrons. That also means I can go ahead and draw my arrow this way. That means as magnesium loses electrons, the ions flow away from the magnesium metals. Magnesium ions are being released into the solution. Over here then, zinc ions are being attracted to the cathode. And as they're attracted to the cathode, the zinc ions gain those 2 electrons and become zinc metal. So we see the zinc ions moving toward the cathode, whereas the magnesium ions are moving away from the anode. The electrons are moving from magnesium to zinc, or to the right the way I have it shown. So then finally, which way do our anions and cations move? Well, they're replenishing the anions and cations that are leaving the solution. So cations are being removed from the zinc side of things. So the cations are going to flow over there to keep the pressure or the electronegativity difference. Whereas over here, anions are going to flow this way to build up the negative charge as electrons flow over to the zinc side. And that's your voltaic cell. And number 10 asks, what would happen if an iron spatula was left in a solution of copper sulfate overnight? So basically, it's asking if you have Fe and have you Cu2 plus, will this react or not? Well, iron is more reactive than copper. And so, yes, I will end up with copper ion, and I'll end up with with iron ion and some copper metal. So what they want to know is what would you actually see, and what you would see is you would see copper metal precipitate. You should see the iron spoon get smaller. And the last thing that IB would expect you to know is that copper sulfate, copper always has a characteristic blue or turquoise color. And you know that because pennies turn green if they get left out in the rain and stuff. So the solution would become more clear or become less blue, because the copper ions are changing to copper metal as they are reduced. Number 11 then wants you to write half equations for the electrode reactions occurring during the electrolysis of the following molten salts. And anytime they ask you about electrolysis, it's going to involve a salt. And generally they're doing it to get the metal out of it. So electrolysis is really pretty straightforward. So you've got KBr, which really consists of a +1 and a -1 ion. So if you have K +1, it's going to tend to, let me get out of this. K plus is going to tend to pick up that electron and become K solid, because that's what you're trying to do, is get the metal out. Whereas the Br minus is going to lose the electron to become Br gas. And to balance this, I actually need 2 Br and 2 electrons. So then this would become 2, 2, and 2 up above. So then B, not very much different. You'll find that electrolysis are really pretty simple. If you have MgF, not sure why that's not MgF2. It actually should be MgF2. They've got that miswritten. But at any rate, you're going to have Mg2 plus is going to pick up 2 electrons to become Mg metal, whereas your 2 fluorine ions are going to become fluorine gas and release those 2 electrons. By the way, as far as which one's the anode and cathode, this is what messes people up. But again, remember, the anode is any negative or any oxidation. So who's losing the electrons up here? Bromine is losing the electrons. So bromine is the anode. Potassium is the cathode. So in electrolysis, your metal becomes a cathode and the nonmetal becomes the anode. And then C, to finish up here, you have ZnS. So zinc is going to start with a +2, pick up 2 electrons to become zinc metal, whereas sulfur is going to start as a -2, become sulfur, plus 2 electrons here. And I'm not sure exactly how IB expected you to realize that sulfur was going to be monoatomic as a liquid. This isn't one I would expect to have show up with sulfur, because sulfur isn't a diatomic gas. If anything, it tends to be S8 as a solid. But that is electrochemical cells or electrolysis.